Okay, so we're going to continue from where we left off, and that's objective 5, writing the tree object. So hopefully this time the video quality will be better, and the sound quality will be better too. It was my first time using OBS Studio, so I'm still experimenting. Hopefully this setup will be great. So yeah, objective 5, write tree object. So let's get write tree. It doesn't really take in any arguments, so it recursively scans the current directory, generate blob objects for files, and serialize directory states into nested tree objects. The trigger is git clone, write tree, deliverables, recursively traverse the current working directory. So ignore the git directory and build directories. For example, target in our case for Rust, because the target directory is the one which usually keeps the build artifacts. So the bins or whatever it is you're compiling. So for files, we write a blob object. Like we did here. So we'll just call the hash object there. Then return the mode. And the file is raw 20-byte hash. Okay, so for directories, we just recurse into the directories and get the root tree hash. So that's the hash of every object, like the combined content of the directory basically. Then we turn the mode. This is the mode for the tree and the 20-byte hash for the tree. So we sort the directory entries alphabetically by name. Then we build the tree payload, so which is tree total payload size, then the entries. Okay, then compute the SHA1 compress hash and compress it with zlib, save to the objects directory, and return the root tree hex hash. Then output print the root tree's 20-character hash. Okay. Sounds pretty standard. Okay. So let's git clone. Okay, so we're gonna create a new command. I'll call it write tree. Write tree. Gonna create another pattern here. Then commands. Write tree. We're gonna create this file. And we're gonna create this function in that file. We're gonna take anything. Okay. Commands. Write tree. You can create that. Okay. Then here we create the function. So it's going to be public one. Calling invoke. Then what are you gonna return? I'm gonna return anyhow. Result. Empty result for now. And okay, I think we're not gonna return anything. We're simply going to print the hash to the screen. So we're going to say okay. So recursively traverse the current working directory. So we need to get the current working directory. So there is a function, yes, this one. So this returns a path buffer. Okay. Current directory. Can add some context there. I don't think this can fail, but anyway, you never know, failed git current directory. Okay, so we have a current directory and we want to traverse the current working directory. Okay, how do we do that? I can use a for loop, obviously, for directory. Let's call it entry. Entry in. There is a function which we could use to read the entire directory. I think it should be read dir. Yeah. So how does this work exactly? It returns an iterator over the entries within a directory. The iterator will yield instances of blah blah blah. Okay. Result dir entry. Ish. Okay. Okay. Entry in blah blah blah. Then we can get the path here. Then you can also check if the path is a directory or is a file. Okay. Seems like exactly what we need. So we want to read the current directory. Okay. I read that. Let me just see that example again. Okay, let entry. Okay. Entry. Now have a directory entry, and from here we can get our path. So entry, I think, is the actual path. Have our path. Okay. So we're in it now. So the thing that we want to check first, we want to ignore the .git directory and also the target one. So we need a if here, if path dot starts with, yeah, so path starts with git, or path starts with target. We want to ignore this continue. Okay. So we're in the directory now. So this is one important detail. We are traversing through the directory. So if you find a directory, we want to go into the directory and do and look for the files again, look for the directories, find another directory, get in there. So I think we might need to create a function here and use some recursion. Recursion makes my brain hurt a lot, right? Tree, and this will take the current directory. Yeah. Taking the current directory, and I think it could return a tree entry. Tree entry. Yeah. Okay. Then this should get in here. Okay, mismatch types. So let's just put this placeholder here. I don't want to see that empty tree. Okay, let's string find tree load to string so we're using the tree entry struct that we made previously, this struct when we were reading the tree. Okay, so we are in the entries. I'm into the entries right now. What are we trying to do? Okay. if the path is a file, if the path is a file, we want to write at the end we want that list, right? We want this list that we had previously, this list. Let me just go around. Yeah, so this list, this is what we want to write to our tree. So we want to hash this. So we want to collect our entries. Want to collect our entries. Just use a Vic here. Okay, so we want to collect our entries, and this file, once we hash it, we define it, be a tree entry, and we push it into the tree entries. That's what we're gonna do here. But we can use what we did here with the hash. Instead of writing everything from scratch, we can simply just use this. So we can just get from here up until here and create a function. So public function hash object, it's gonna take in file path, which can be a reference, a string reference, and it's gonna return anyhow result of string. So it's gonna return the hash. It's gonna return the hash. So we can actually just call it here, say our hash, to just clear the errors. Our hash is a hash object file path. Yeah. Path. So we still need a compressed state, so I think we can simply return a tuple. So this would be string and big E8. So we return the hash and our compressed data. Compressed data, then here we can simply change that compressed. Okay, we can just look into this function now. Paste this. So at the end of this function, we can return, okay, our tuple with hash and compressed. Okay, is that working out? Is that working out? Okay. What's going on? Yeah, that's what's going on. Nice. So now we can simply call this function. So calling it here and also calling it there. So we can get, we don't need the compressed data, but we can just say, so we can just get the hash and discard the compressed data, and going to commands, hash object file path. We're gonna take in the path, but this is a path object, so to string wrap. Okay. Oh, wrong spelling here. Hash. Okay, so we have a hash. Have a hash now, and we want to make an entry. So let's just tree entry, tree entry, to tree entry, name, okay, mode, kind, name, hash, okay. So mode is since it's an object, this is, what's our number again? 106.4 to string. Okay. Then our name, we're just gonna use path to string. It's required an actual string. Okay. Then comment block times block. Then our hash. Okay, so we've made our entry, so that's a file. So if we stumble upon a file, easy, light work, just do that. And if our path is a directory, we are going to have to recurse. If our path is a directory, we call our function again and then make a tree entry. So our function already returns a tree entry, so we're just going to let tree entry to right tree. So we're going to put in the path. Then, oh sorry, I forgot to push this in. So push tree entry. So even here we have our tree entry, tree entries. Okay, so tree entry. Okay, so that's if it's a directory. Okay, looks pretty solid. That looks pretty solid. Okay, so we're recursing to the directory, and now we've recursed into the directories, right? We're assuming we're done here. We're done doing that. So we want to sort the tree entries first. Let's sort them. So they're sorted out now. So, okay, mode, name, kind, hash. Okay, then we want to build this tree payload. How is it supposed to look like? Okay. How we're going to do that? Let's just call it tree payload. You're gonna use the break again. It's mutable. So okay, it's mutable. I'm going to write to it total payload size. Okay, so we write, and I use our write here. Tree payload. Okay, put a tree here. Payload size. The entries. Payload size here. I think we can simply do that. Then tree entries. Total length. Okay. Okay, I think we don't have the right trait. Yes, we don't have the right trait in this space. So use standard IO right. Okay. Let's put some context here. Payload to actually payload. Okay. Okay, so we've added that. Then now we can simply extend that with our tree entries. Reference to our tree entries. Is not satisfied. Extend. So tree entries. Okay. That's why. Because it's a Vic of tree entries. It would have been easier to extend if this was not a Vic of tree entries, but it was a Vic of U8s. Okay. No problem. No problem. What can we do here? Is not satisfied, is not implemented for Vic U8. Okay. Do we turn this into U8s? I really like the tree entry abstraction. it's pretty good to work with. It's easier to work with. But once we just do that, then it's game over. So what do we do? Do we change the mode of entry to U8s? Or do we find a way to extend our tree payload with the tree entry type? Maybe it will be easier. Maybe it's easier to what's the best way to do this? What's the best way to do this? Push that, push that, push that, push that. Kind of stuck here. Can we extend? Can we implement the trait? I think that's too complex. That's just like way too complex for the problem. Maybe it'll be better to tree entries. Maybe we can take these tree entries and put them in a different format. So we could write it again. We could write mode name that. Yeah, I think we could perhaps we could write it again. Let's do that. Tree new. So for tree entries, we write to that. Yeah, that's pretty solid. That sounds pretty solid. So I'm going to make this readable. To make this info here. Then it puts it in here, tree data. Then we follow the format, mode, name, the null value, the mode, name, null, then hash. Nice. So we could simply say entry dot mode, entry dot name, entry dot hash. So yeah. Entry dot mode, entry dot name, right. Created unit type. arguments. Yeah, should work. Why are we getting this? Found result error mismatched. It's possible that this entire line. That's so stupid. That's so stupid. So, okay. So now we can extend that with the tree data. Nice. So here, I have to use a reference. Okay. So we extend that with the tree data, and now we have our full payload. So we have to compute the SHA1 compressed with the zlib. Okay. So tree payloads. Let's call that row hash and SHA1 digest, and we put in our tree payload. I've already the actual hash as this fixing code here like we've been doing, and have our string, which is the hash, and we could simply okay, no, not really. So this already goes here, hash. So tree payload. Okay, what's next? Compress with zlib, save it there. Okay. Mode. Okay, mode, that's 400. How many zeros should that be? Yeah, that's not zeros. Then the name, we can simply give the current directory to string again. Where do we move this? Okay, there. So we're gonna press a reference here. Slow movement. Okay, so we have that, we have this, we have that, we have this. Okay. So here we can simply say tree is equal to write tree passing our current directory, get our tree entry, and let's see if we can print out the hash. Okay. So let's see if that works. Okay, it's running. If it takes too much time, then it's an error. And that's an error. That's a huge error. Let me see. So there's something wrong here when it's just taking its time. I mean, we are ignoring git and we are ignoring target. We shouldn't necessarily have a hard time, but it's running. Yes, we have our hash. Nice. So the other part of this objective is to actually store this. Okay, and to store this and to compress it and store it. Let me just copy some code here. Where were we compressing things and storing those things? So Zilib encoder compression here. Okay. Yeah, compress. Just let's copy this. Okay. And continue from here. Zilib encoder compression. And what we want to write? We want to write the tree payload itself. Okay, we can import this. This will be imported as well. Okay. Have our data that's compressed, and now we need to write it. Okay. Let us get this. Okay. Yeah. Just okay. So writing that there, field right tree file. Okay. Hash. So object path. Get the hash here. Split that. Object path to push the dir, push the file tool, create the directory or create the file, write to the file. Nice. Let's just do that again. Take some time. I don't know, maybe it'll be faster on a failed to create object file, permission denied. Huh. Oh, why is that? Why is that the case? That should not be the case. Failed to create object path, object file right here. So have the directory there. Failed to create object file. Object path. Very interesting. Object path. I think maybe we should not. We should simply do this and not add parent here. Let's try again. I mean, that was just a guess, though. I didn't actually think through what just happened, why the error might have actually come about. Could be my permissions. Could be my permissions. Failed to create object file. Okay, still. So path is being created. The file itself is the one which is maybe it's because it already exists. So can I go up here? Can't. Maybe it's because it already exists. Let me What should I try? What should I try here? Should I try deleting everything in the objects? Okay, that's a lot of objects. That's a lot of objects. Let me not create anything then. Just for now. I will figure out exactly what's going on here. You know the hash. Let's see. Can I get the actual hash and see if it's already created? Because maybe I might have maybe Git writes the tree every time you like commit or add. Maybe that could be the case. Okay, maybe this is coming too long. Let me just pause. Okay. So it turns out it is already been created somehow. Could be the real Git. Let me just. I just want the real Git. It's the code itself. Okay. My fault. My bad. This is, of course, it's being created over and over again. It's in the recursive loop. So I'm just gonna take tree payload. How can we write this? Maybe we should write it after this. We can use it's definitely because of the recursion that's going on here. That's why it's being written over and over again. I think maybe we could skip if the tree has already been written. So if the object already exists, that means we've written it already, then we can skip it. So okay. So if object path dot exists, returns true if the path points to an existing entity. Okay. So it does not exist. Let me put this. Okay. Is that alright? Is that alright, guys? Can't go wrong. Let's try it again. It takes too much time. Need to find the reason why that's happening. You can hit me up in the comments if you figure that out. But it should, maybe it's just my system. Hopefully it runs fast on some of your hardware. Still running. Okay. So 264. Let's see. It object D26. Yeah. Okay. Think this. And that's it for today. See you all soon.